Hello everyone, today I have something to present to you about complex numbers and roots. So what I will be presenting today is this equation that I will write for you right now. So here is the equation that I am going to solve today. X to the fifth power is equal to x minus 1 to the fifth power, where x belongs to complex numbers. Now, there is a way to do this that I've seen, and that is to factor this out. Yeah, and all that. There are many ways. Substitution also works, but taking the fifth root on both sides doesn't work in the real world, because that would result in x is equal to x minus 1 minus x on both sides. We have 0 is equal to minus 1, and that is false. So that is not real. No real solutions exist here. But as I said, x belongs to complex numbers, so I will be showing you a way to do this in the complex world using polar forms. But before I show you how to do this, I will be showing you some more simpler stuff first about this way. This technique that I will be using polar forms, I have never seen anyone else do this before. There might be some people who have done this method before, but I have not I have not seen anyone use this method before. And yes, I actually figured this method out myself. I actually found out about this myself. So I'll show you right here. So before we go to do anything hard like that, we will do this first. And yeah, this is x belongs to complex numbers as well. So usually when you see this, you minus 1 on both sides and then factor it out. Get x minus 1 to here, and we will have x is equal to 1 as the first answer. And then another quadratic where we can use a quadratic formula or just complete the square. And you get all the three solutions. But that's a lot of hard work. Let me show you the polar form way. So first of all, we would want to visualize first what the third root means. What the third root means? Well, the third root just means a number multiplied by itself 3 times to get 1, right? Well, if you think about it in a unit circle, we can draw a unit circle first. So that point right there is 1, right? Which number multiplied by itself 3 times equal to 1? Well, there are 3 numbers in this case. 1 multiplied by itself 3 times, pretty much 1 rotates by 1 3 times. So it just rotates 1, 2, and 3. That's 3 times, and we do get 1. That is correct. So 1 is an answer. But there are 2 more solutions, which they are complex. So how do we do this? Well, actually right here is imaginary. And then right here is real. I'm just going to write it like that. Okay, so this is 1, but there are actually 2 more roots, which are actually here. Right? Just divide it into 3 zones. Okay, maybe my drawing is a little bit bad, but you know, 3 equal slices. Yes. So this is the first root, which is 1. But what is this root? Well, in order to find this root, we need to find the angle here. And first of all, we have to convert it to the polar form. So how do we do that? Let me show you right here. First of all, we have to rewrite 1 into the polar form, which is actually e to the 2 pi I. Yes, e to the 0 I also works as 1. E to the 4 pi I also works as 1. And plus 2n pi, yes, where n is an integer, but we're not going to worry about that. We're just going to use 2 pi I. So let me show you now. So right here we have x cubed is equal to e to the 2 pi I. 2 pi is the angle right here, which is the whole thing, which is one circle, right? If we want to divide it into 3 equal zones, what do? Yes, we just divide the angle by 3. And that is what we're doing here. There's a root, there's a cube root. We do a cube, there's a cube. We do a cube root, and that slices the whole circle into 3 zones. That's what it does. So let me show you now. So yeah, we changed the cube root into an exponent, which is 1 over 3. So we do that, and this is the principal root. Yeah, I guess the principal root you'd say is actually 1, but in this method, the principal root is the first one you get here, which is the first slice. So this 2 over 3 pi is actually the angle for here. Yep. This is actually 2 over 3 pi. Now, how do we find this angle? We just have to rotate it more. And yes, every slice is equal. So this is just 2 over 3 pi plus another 2 over 3 pi, which is actually 4 over 3 pi. And yes, that is correct, 4 over 3 pi. But this is 4 over 3. This is actually, you can actually simplify this a little bit. And how do we do that? We can actually just rotate from the other side. And when we rotate it clockwise instead of anti-clockwise, we have to make the angle negative instead. And in this case, the whole circle is 2 pi radians, right? So this is 4 over 3 pi. And we just have to subtract that from 2 pi, which we would get minus 2 over 3 pi. So the angle here will be minus 2 over 3 pi because we're going on this direction. That's why we have the negative. Okay, so that's actually the second root, which is right here. So the first root is here. We rotate it by 2 over 3 pi, we get this. Second root is here. We can rotate it more by 2 over 3 pi, which total is 4 over 3 pi, which it is correct, but we can simplify it a little bit by rotating it from this side, which is minus 2 over 3. So yes, we have the first solution here, which is x is equal to e to the 2 over 3 pi I. That is correct. Second solution we have is x is equal to 4 over 3 pi I or minus 2 over 3 pi I. That is also correct. Now, once we are here, what do? We add another slice, which is 2 over 3 pi. What happens if we add 2 over 3 pi here? We get 0. E to the 0 I is just e to the 0, and e to the 0 is just 1. So that is, there you go. Yep. These are the 3 roots, and they do work indeed. They are in the polar form. You can convert it into Cartesian form by using cosine of angle plus I times sine of the angle, and you get it. But this is also correct because this is just a constant. So yeah, they are solutions, and this is correct. Now let me show you more. Another example. So this time we will be doing it on minus I instead of 1. So how do we do this? Again, same thing. Let's first of all write a unit circle. Draw, not write. So there's a unit circle. Minus I. Minus I is here, right? So this is minus I. So yes, same thing. Split it into 3 zones like that. And now we have to find the 3 roots. So first of all, we will start by changing it into polar form. Same thing, right? So yeah, let's just do that. X cubed is equal to minus I, we can rewrite it as e to the minus pi over 2I. Right? Yeah. So there you go. E to the minus 1 over 2 pi I. Now, what do we do again? Yes, we take the cube root on both sides and divide by 3 in the angle. We get 2 times 3 is 6, so we just rewrite that as a 6. Right. So that is not the principal, that is the principal root in this case, with this method, but we do not add the angle by 1 over 6 pi like we did last time, because that last time it was 1 and 1 starts as 1, right? But this time it's minus I, and this is from minus I. So in order to find one slice, we need to go back to 1. So we will go back to 1 first. So we will do the same thing here. 1 is e to the 2 pi I, and then we take the cube root, so over 3. And this is the angle. This is the angle that we want to add into it. But the difference is this time it's negative, and if it is negative, then we go this side first instead of that side. And actually, I think the picture might be a little wrong. Anyway, this is the first one. So we rotate it first to this side, and then we add it by this one, but we don't add it this time because it's minus. So we just subtract it again, and it just goes this side. So the first root, let's rewrite it here. So first root, we have x is equal to e to the minus 1 over 6 pi I, right? And then second root is x is equal to, we will subtract it by this one to continue the term, which is 2 over 3 pi is 4 over 6 pi, which minus that is 5 over 6 pi, so e to the minus 5 over 6 pi I. So that would rotate it more. And now for the last slice, we just have to rotate it one more time, which is 3. So x is equal to, and then subtracted by 2 over 3, which is 4 over 6. So we have minus 9 over 6 pi. But as I said, if it goes there, what we can do is just subtract it from 2 pi. And then because this time it's negative, we have to make it positive. So just absolute. So minus by 2 pi, that would be 9 over 6, 9 minus 12 is 3. So that's that's 3 over 6 pi, which is, and it's positive, so that's 1 over 2 pi I. And yeah, that is correct. So I think the only mistake I made here is it's upside down. So let me redraw that. Yeah, it's probably upside down. So here, this one is here. And then this one is, okay, wait, this one is here. So that's 3. And then the first one is here, okay. There you go. So this one we rotated here first, and then the second one we rotated here. And then the third one we rotated all the way here, but we can then rotate it from the other side, which is positive, here instead. So this is 1 over 2 pi. This is minus 1 over 6 pi. And here is minus 5 over 6 pi. And then here is minus 9 over 6 pi. All right, so that is done for this one. But let's try a little bit harder for that one. But before we try that one, let me just prove that we can indeed just put the magnitude and the direction separated and then multiply it back in together. And I will show you what I mean in a second. So here, same format. If we do a positive square root, then it has no answers. But what I mean is if we do a square root and then plus minus, which actually same exact thing as the spinning thing earlier, except plus minus because square root is just here and then here, so it's just plus minus. So let me show you. So what I will do is just a square root and then multiply by plus minus. Here we do a square root, right? And then here also a square root, but then I will multiply by plus minus. Just like that. So now that I've done that, this part is like the magnitude part, and then this is like the direction where plus and minus can occur. So now what we have is two scenarios. The first scenario is being positive, so let me show you. So x is equal to x minus 1, x minus x is 0 equals to minus 1, that is false. So this whole thing is wrong. However, the second scenario where it is negative, we have x is equal to, distribute the negative here, we have minus x, and then minus times minus is plus, so we have that. And now that we have that, we can move that to the other side where 2x equals 1, and then divide by 2 on both sides, so we have x is equal to 1 over 2. Yes, and that is actually a correct answer, which means that this means that if I do this, but with fifth root instead, it should work, because in this case, what I did was I just multiplied the direction here and then took the magnitude, separated it. So this would work, and I will show you in a bit. So here it is. It's time for the moment that you have been waiting for. Let's finally solve that equation. So here we go. This is how I'm gonna solve this. So first of all, yes, take the fifth root on both sides, just like that. But we are not done, because that is only the magnitude. We have to multiply it by the direction, which I will put it as the fifth root of 1. But we will use the rotation thing to find all solutions for this. So first of all, let's find all the solutions for this. Wait, actually no. Let's solve this first in terms of this, and then we will solve all the solutions with the spinning thing, polar form. So x is equal to, let's distribute this thing in, so we have fifth root of 1 times x, and then minus this thing, which is fifth root of 1. Okay, and now let's move x to the other side and factor x out, so we have x times 1 minus fifth root of 1 is equal to minus fifth root of 1. And then we move that to the other side, so we have x is equal to minus fifth root of 1 over 1 minus fifth root of 1. But the fifth root of 1 is not just 1, because we want all the complex solutions. Right? Right. And that is why we will have to spin this thing again. So now what I will do is I will spin it. So let's move here, and then we will spin it on this side and then copy it on the other side. So again, let's draw a unit circle. And now this time it's 1. It starts with 1, so it's easy, but we have to split it into 5 different zones. So that would be here, here, 1, 2, 3, 4, 5. Okay, that works. The angles are not exactly equal because my drawing is bad, but you know what I mean, right? So yeah, there's that. So what I'm gonna do is, this is imaginary and real. So we have fifth root of 1. Let's rewrite 1 in polar form. So we have e to the 2 pi I, and then the fifth root, so over 5. And that is the angle that we are talking about here. 2 over 5 pi. Right, so this is the angle here that we are talking about. So now we just have to rotate this 4 more times. So this is the first direction. Second direction here, added by 2 over 5 pi. We have 4 over 5 pi, and then added by more. We have 6 over 5 pi. We can simplify that, and I will do that actually. So that would be minus 4 over 5 pi. And then we go more to this side by 2 over 5, which that would be minus 2 over 5 pi. And there you go. That is all that we have. So we have 1. We have 2, which is e to the 4 over 5 pi I. 3, which is e to the minus 4 over 5 pi I. 4, which is e to the minus 2 over 5 pi I. And lastly, we add 2 over 5 pi into this, which 2 over 5 pi minus 2 over 5 pi is 0. And e to the 0 is just 1. However, 1 in this case does not work in this solution. So we can just cancel that out, and these are the 4. So let me substitute them in back here again. Okay, so yes, we will substitute the 5th root of 1s back in with those directions that I have. So first solution we have right here, minus, and then over 1 minus. And then we have e to the 2 over 5 pi I. And here we have e to the 2 over 5 pi I. Yes, that is the first solution. Second solution, same thing, minus and then 1 minus. You know what, let's just write them all. So here we have e to the 4 over 5 pi I. And here we have e to the 4 over 5 pi I as well. That looks ugly, let me rewrite that. And then here we have e to the minus 4 over 5 pi I, and then e to the minus 4 over 5 pi I, like that. And then the last one, e to the minus 2 over 5 pi I, and then e to the minus 2 over 5 pi I. There you go. Those are the 4 solutions that we have. Whoops, I dropped my marker. The 1, if we plug 1 in here, we have, as I said, 0 equals minus 1, and that's false. So let's do that. Let's box them in. Just like that. And yes, you can check those out by using Cartesian form, cosine, theta, plus I sine theta. And yeah, you can check that out if you want. But these are the 4 solutions right here. There you go. 3, 2, 1, goodbye.